Hey everyone, welcome back to my YouTube channel. My name is Veronica, also known as Data Geek is my name. So if you are new here, please hit that subscribe button, turn on the notification bell, because you don't want to miss weekly tutorials that level up your data skills. So let me ask you, have you ever wondered how AI actually thinks? Like, how does Netflix even know what movie you'll end up watching? Or how does even YouTube end up recommending a video you end up loving? Well, today I'm going to show you exactly how these machine learning algorithms work, using simple steps, visuals, and Python code that even a beginner can follow along. So if that's you, you're in the right place. So let's get started. So before we get started, what you'll learn in this tutorial is you'll learn what machine learning really means, how to prepare and visualize data, how to train 3 beginner machine learning models, which are linear regression, decision tree, and the KNN. It's okay if you don't know what they are right now, we will go over these. Next, you will learn how to compare results and test predictions. So why learn machine learning? Well, it's behind every smart app you use daily. It helps businesses make better decisions, and it's super valuable, believe me, super valuable for skills for data analysis and developers. So what you'll need in this tutorial, you'll need Jupyter Notebook. It could be inside Anaconda Navigator or Google Colab. If you want to know how to download Anaconda Navigator, I have a video on that. I will link that in the description below so you can have access to that tool to navigate Jupyter Notebook. Also, the Python libraries that you will need in this tutorial are Pandas, NumPy, Matplotlib, and scikit-learn, and the dataset. For this tutorial, I will be using the sales_prediction_machine_learning.csv file, and I will link that in the description below, so that way you can use the same dataset. So this is a step-by-step roadmap. So this is what we will do first. We're going to load and explore the dataset. We're going to visualize the data. Then we will split into training and testing sets. Then we will use the 3 models that I mentioned before to train the data. And then we will compare and visualize results. And lastly, we will make your own predictions. So what is machine learning? So machine learning is the science of teaching computers to learn from data and make predictions without having to write every single step or instructions. The computer does it all for you just by reading all the data. So here is a formula that I want you to remember. Machine learning equals data plus algorithms plus experience. So I want you to stay till the end because there is a bonus, a live what if prediction demo. And also I'm going to give you a free downloadable notebook, so this code for free, and also the data set that we will be working with. So finally, let's get started. Open up Jupyter Notebook and follow along. We'll code, visualize, and predict step by step. So I'll see you inside. All right, so here I am in my Jupyter Notebook. And once you are here, all you have to do is click on Upload here on the top left. And then your file location, which I have it under my documents. Here it is, sales prediction. Click on it and then click Open. So then once you do that, you scroll down to the bottom. You will see these little green windows. Those are CSV files. And you will see it here, sales prediction_ml.csv. So this is the CSV file we will be working with. Now to create a new workbook, you simply just click on the new button here on the top right and click Python Conda. It might be different for you. It might be new workbook. Either way, you're going to click on that. And now here is your new workbook. As you can see, Jupyter Notebook has cells. So every cell you enter in your code. I will just add a few of them. I'm going to put a title here, which is a markdown, a number sign, step 1. We will be importing libraries. So if I run this, it will run as a caption. First, we grab our tools. We call them libraries. This helps with tables, math, and charts. So if you are missing any of these, you will install with a simple line of code, pip install pandas, numpy, matplotlib, seaborn, and scikit-learn. Once those are installed, then you can import those libraries. So we are importing pandas as PD. This helps with tables just like Excel. Then we import numpy as NP. This helps with math and arrays. And then we import matplotlib.pyplot as PLT. This one helps with charts. So then here we put a plt.rc params. So what this is it's matplotlib. So PLT refers to matplotlib's pyplot, and that's the part of the library used to create charts and plots. And then the RC params is like a global setting dictionary for matplotlib. You can use it to control default look of all your charts, such as font size, colors, or figure dimensions. So basically this line sets the default figure size for all plots you create. So every time you run plt.plot with an open and closed parentheses or another matplotlib chart, it will open with a wide of 7 and a height of 5 in inches. With all that, you're just making sure every chart has a consistent size, not too long and not too small. Perfect for tutorials and reports. This next part is for prettier charts. It's a seaborn setup. So the try and the expect, this block is checking if seaborn is installed on your computer. If it is, it sets up seaborn theme. If not, it quickly skips it without crashing your code. The sns.set_theme. The style ticks. This tells seaborn to use built-in visual themes called ticks. It makes your charts look cleaner, smoother, and more modern than a plain matplotlib default. You get nice grid lines, better color palettes, and improved readability all automatically. And the has_seaborn equals true. This is just a flag variable, a fancy way of saying a marker. So with all that said, this little code block ensures that your charts always have the same nice looking size. Your visuals automatically look better if seaborn is available, and your script won't crash if someone runs it without seaborn installed. Now we're importing a few essential tools from scikit-learn, one of the most popular machine learning libraries in Python. So this train_test_split, this helps us divide our data into a training and a testing set so we can see how well our model performs. Then we have 3 different algorithms. We have the linear regression, we have the decision tree regressor, and the k-neighbors regressor. But each one learns patterns in a slightly different way. Finally, the mean_absolute_error and the R2_score are evaluation metrics that tell us how accurate our predictions are. So this whole thing here is our toolkit for training, testing, and measuring the performance of our machine learning models. All right, so before we run this code, this here, I'm going to put a number sign and make it a comment because I've already done this step. But if you have not, make sure to install those pandas, numpy, matplotlib, seaborn, and scikit-learn. Then once you do that one time, you can go ahead and start using the libraries. So in this case, I've already done this step, so I don't need to. So I'm going to put a number sign here, and then I will run this code. And it ran successfully. So now we will go to step number 2, where we're going to load and peek at the data. Let's load a simple data set about sales. We'll predict sales using budget, price, and website visits. So here we're using the CSV_path to read our sales_prediction CSV file. And then we name it df, which equals to the pd.read CSV file, which is a pandas library that we're going to read this CSV file. Then we add the df to df.head to display the first 5 rows of our data set. And as you can see, it has 5 rows, so there's a numbering row column. And then we have advertising budget, which money spent on ads. Then we have our product price, which has our price per unit. Then our website visits, so that's number of visitors. And then our sales column, which total sales, this is our target to predict. This step is always recommended because you want to look at your data before you actually start cleaning or doing any type of analysis. That way you can get a look at your data and see what you're working with. So now step number 3. So here we want to display any NA values or sums. There we go. And now we will go ahead and run this code. So this is a quick data health check. And we see that budget, product price, website visits, and sales columns have all zeros and have no NA values. It gives us our data type, which is integer. Now this df.describe gives us this table down here, which is very good to see the short statistics. So our advertising budget, product price, website visits, and sales, those are our sales columns. And then here, count, mean, standard deviation, min, 25% quartile, 50%, 75%, and max. It gives each row a number for each of those columns. So you get the count for advertising budget, the mean, the standard deviation for each of those columns, and so on. It gives us good information on basic stats of our data set. Now going to step number 4. So here in step 4, we're going to visualize relationships. So pictures make patterns easier to see. So let's look at pair plots and heat maps. Here we're making sure our data set has all the right columns we need. Things like sales, advertising budget, website visits, and product price. If any of these are missing, Python will give us an error message so we don't run into problems later in our code. Next, if Seaborn is installed, we use it to create 2 visuals. The first one, called a pair plot, shows relationships between all the numeric columns. For example, how sales change with advertising or visits. The second one is a heat map, which shows how strongly each variable is related to the others. And if Seaborn isn't available, no worries. We just make a simple scatter plot showing how the advertising budget affects sales. This will help us understand our data visually before training any machine learning models. And we will run this code. And it ran successfully. So scrolling down to see our visual, taking a look at this chart. This is called a pair plot. I'm going to zoom out so you can see more. And then on the bottom here is a heat map. So the pair plot shows how all numeric columns in our data set relate to each other. Each dot that you see represents a data point. And these dialog plots shown in the middle are called a histogram. And these show each variable. So this one's advertising, this one's product price, this one is website visits and sales. This helps us see how values are spread out. So the scatter plots below and above these diagrams show relationships between the 2 columns. For example, you look at website visits and sales. you can see a strong upward pattern, meaning that as our websites increase, sales also go up. On the other hand, the other variables like product price or advertising, these two, you see that they're scattered. They don't show as clear of a pattern, so which tells us these might not have a strong direct relationship with sales. So looking at this, you can see that sales has a stronger relationship with websites. So this type of visual helps us quickly spot trends or patterns before building a machine learning model. Now let's look at the correlation heat map. So this is the correlation heat map. So you have advertisement budget, product, you have all of your variable names here and also here. So that way you can see like advertising budget, and then this column is advertising budget. So of course it's going to have a strong correlation because it's the same column. Same with product price. But as you can see, the darker the color, the stronger relationships. So for example, look at websites and sales. So websites here and sales, this is where it's at because sales is here. So here is 0.97, which means as website visits increase, sales also increase. On the other hand, product price and sales have a negative 0.05, which doesn't seem to affect sales much since the correlation is pretty much close to 0. So from this heat map, we can quickly understand which factors have the biggest impact on sales before building our machine learning models. Now going to step number 5. Change this to a markdown and run this. Now that we've explored our data, it's time to prepare it for our machine learning model. Here I'm selecting the columns that will help us predict sales. Those are advertising budget, product price, and website visits. These are called our futures, and they go into the variable X. Then the column we're trying to predict, which is sales, is our target, and it goes into the variable Y. This is really important because it tells a model what inputs to learn from and what output to predict. So now we'll go ahead and run this code. And here is our output. So we have advertising budget, product price, and website visits. Now going to step number 6, we're going to split into train and test. Next, we're splitting our data into 2 parts, training data and testing data. The training data is what the model will use to learn the patterns and relationships in our data set. The testing is what we'll use later to see how well the model performs on new unseen data. Here I'm using the train_test_split function from scikit-learn and setting the test size to 25%, which means 75% of the data will be used for training and 25% will be used for testing. This is a very important step because it helps us evaluate whether the model is truly learning or just memorizing. Okay, and I will run this code. And it gave us an output of training rows. So they're going to train this rows 150 rows. And testing rows is 50. So just as we described, testing size is 25, which is lower, and the random state 42, which is going to be higher. So step 7, we're going to train 3 models, the linear regression, decision tree, and KNN. So the linear regression draws the best straight line to predict numbers. Decision tree asks yes, no questions like a flowchart, and the KNN looks at the closest examples and averages them. Okay, we will run this code. All right, so here it says in line 1, the linear regression. Here I put a space, so make sure you put that all together. Sorry guys, and let's run this again. Great, the model is trained. we measure performance using the MAE and R². MAE shows the average error, smaller is better, and the R² shows how well the model explains the data. And this case, closer to 1 is the best. All right, and we will run this code. And now in line number 11, R2, which is the R², let's see what's going on here. So is not defined R. So here in this line, I put R² equals R2, which should be underscored. So now it should be R2 underscore score. Let's run this again. And perfect. It ran successfully. All right, so here is our model. Looking at our model, so this is the linear regression line, the K&N line, and the decision tree. Here on the top is just what we named these columns, which in this case it's going to be the MAE model. Lower is better, and the R² closer to 1 is better. So looking at these columns, the linear regression, you can see that this number is smaller than the rest, so it looks like it performed the best, with the lowest MAE and around 465, and the highest R² value, which is 95%, closer to 1. That means it predicts sales with the smallest average error and explains about 95% of the variation in the data. And next is the K nearest neighbors, which is the K&N. Looks like that came in second, doing a decent job with the R² of 93%. And lastly, the decision tree. This model performed the weakest here, with a higher error and a lower R². So in this case, the linear regression gives us the most accurate and reliable predictions. Now going to step I'm going to add more cells also so I can move up more. So in this case, we're going to visualize actual versus predicted. If points hug the dashed line, predictions are close to the truth. All right, so now we will run this code. And it ran successfully. Now, let's visualize how well each model predicted the sales. This function compares the actual values on the x-axis to predict values on the y-axis. The closer the points are to the dashed line, the better the model predicts. So when you see the dots closer hugging that line, that's a sign of strong, accurate data. So now let's start with this actual prediction with the linear regression. So again, as I told you, the more the dots hug this line, the better the prediction is. So looking at the linear regression, notice how most of the plots are very close to the dashed dialog line. That means our predictions are pretty accurate. The model is able to capture the relationship between cells and other features very well. As you can see, some points might be slightly off, but overall it's doing a great job. So let's scroll down to our decision tree. You'll notice the dots are more scattered and don't stick as closely to the dialog line. That means its predictions vary more. It tends to overfit the data a bit, learning too much from the training set and not generalizing it as well. So in this case, the decision tree isn't performing as strong. So let's go to the next model, the K&N, and see how that one did. So this is the K nearest neighbors, so the K&N model. So you can see that the points are following the same general pattern as the linear regression, but they're scattered a little more. So that tells us the model isn't quite as consistent. It performs well for some predictions, but struggles a bit with others. So it's still decent, just not as precise as linear regression. From looking at these, we can see that the decision tree didn't perform as strongly as the others, and the KNN performed well but not as good as the linear regression. You can see that the linear regression did a great job on predicted sales. By comparing all three visuals side by side, you can really see how linear regression gives us the smoothest, most reliable prediction, making it the best fit for this data set. Now going to step number 10, this is going to be a what-if scenario. So let's imagine we spent $5,000 on advertising, price our prediction at $40, and get around 2,000 website visits. We'll feed these numbers into each of our trained models to see what they predict for total sales. Now, this equal signs symbol, it means approximately equal to. So to do this on your keyboard, I'm using a Windows. So you're going to hold the Alt key and type 247. And it will appear. And for Mac users, press Option plus X. For Linux, Control plus Shift plus U. Then type 2248 and hit Enter. And now we will run this code. So here under print scenario, after the double quotation, put a comma. And run this again. And here is our output. So the linear regression model predicts sales around 3,914. The decision tree model comes in slightly higher at about 4,409. And the k-nearest neighbors model estimates around $3,867. $3,868 rounding up. You can see while the numbers are close, each algorithm gives slightly different outlook. And that's because each one learns patterns in a unique way. This kind of what-if testing is really useful for when you want to forecast sales, test marketing budgets, or make data-driven business decisions. It's one of the coolest parts of using machine learning for real-world insights. And that is it. We just built and tested multiple machine learning models in Python to predict sales and even ran a real-world what-if scenario. You've seen how easy it is to move from data to prediction, and that's a huge step in your data analysis journey. If this helped you understand machine learning a little better, don't forget to give this video a thumbs up and subscribe if you haven't already. That helps my channel grow and lets me keep making free beginner-friendly tutorials just like this one. Thank you for watching. My name is Veronica, also known as Data Geek is my name, and I'll see you on the next video.